Good evening. Today I am going to discuss about 555 timer. The introduction of 555 timer. The 555 timer is one of the most popular and versatile IC ever produced. Signetics Corporation first introduced this device as the SE bar NE 555 in early 1970. It is a combination of digital and analog circuits. It is known as the time machine as it performs a wide variety of timing tasks. Application of the 555 timer are ramp and square wave generator, frequency dividers, voltage controlled oscillators, pulse generators, and LED flashers. The following figure shows the pin diagram of 555 timer. It is a 8 pin DAL and integrated circuits or chip. So it has 8 pins. The pin description of 555 timer is the pin 1 is the ground, that is low level 0 voltage. The pin 2 is the trigger, that means it out rises and interval starts when this input falls below 1 by 3 VCC. The pin 3 is the output. This output is driven to approximately 1.7 voltage below plus VCC or ground. The pin 4 is the reset. A timing interval may be reset by driving this input to ground, but the timing does not begin again until reset rises above approximately 0.7 voltage. The pin 5 is the control. Control access to the internal voltage divider. The pin 6 is the threshold. The interval ends when the voltage at a threshold is greater than that of CTRL. The pin 7 is the discharge. It is an open collector output may discharge a capacitor between intervals in phase with output. The pin 8 is VCC, that is positive supply voltage is usually between 3 and 15 voltage. Then inside the 555 timer, what are the components present? Inside the 555 timer, the voltage divider has 3 equal 5K resistors. That is, 555 timer will have 3 equal 5K resistor. It divides the input voltage into 3 equal parts. The two comparators are op amps that compare the voltages at their inputs and saturate depending upon which is greater. First comparator is threshold comparator. It saturates when the voltage at the threshold pin is greater than that of 2 by 3 VCC. The trigger comparator saturates when the voltage at trigger pin is less than 1 by 3 VCC. The flip-flop is a bistable device. Here RS flip-flop is used. It generates two values, high value equal to VCC and a low value equal to 0 voltage. When the threshold comparator saturates, the flip-flop is reset and its outputs a low signal at pin 3. When the trigger comparator saturates, the flip-flop is set and its outputs a high signal at pin 3. The transistor is being used as a switch. It connects pin 7 to ground when it is closed. When Q is low, Q bar is high. This closes the transistor switch and attaches pin 7 to ground. When Q is high, Q bar is low. This opens the switch and pin 7 is no longer grounded. Uses of the 555 timer. 555 timer will be used as a switch on or off an output after a certain time delay. Examples are games timer, child's mobile, exercise timer, and it is used as a continually switch on and off an output, that is warning lights, bicycle indicators, and it is used as a pulse generator, that is to provide a series of clock pulses for a counter. 555 timer will operate in 3 modes. that is monostable multivibrator, astable multivibrator and bistable multivibrator. Today we are going to see about monostable and astable multivibrators. This is the circuit for monostable multivibrator. The description of this circuit is in the standby state, flip-flop holds transistor Q1 on, thus clamping the external timing capacitor C2 ground. The output remains at ground potential, that is low. As the trigger passes through VCC by 3, the flip-flop is set, that is Q bar is 0. Then the transistor Q1 off and the short circuit across the timing capacitor C is released. As Q bar is low, output goes high. This is the output waveform for monostable multivibrator. Voltage across it rises exponentially through R towards VCC with a time constant RC. The voltage across the capacitor is given by VC is equal to VCC into 1 minus e power minus t divided by RC. The monostable multivibrator is constructed by adding an external capacitor and resistor to a 555 timer. The circuits will generate a single pulse of desired duration when it receives the trigger signal. Hence, it is called a one shot. The time constant of the resistor capacitor combination determines the length of the pulse. Uses of the monostable multivibrator, it can use as the used to generate a clean pulse of the correct height and duration for a digital system, and used to turn circuits or external components on or off for a specific length of time, used to generate delays, and can be cascaded to create a variety of sequential timing pulses. These pulses can allow you to time and sequence a number of related operations. Then second mode is astable multivibrator. So this is the circuit for astable multivibrator. A stable multivibrator will be constructed by connect external timing capacitor between trigger point and ground. It split external timing resistor R into RA and RB and connect their junction to discharge terminal. That is pin 7. It remove trigger input. Monostable is converted to astable multivibrator. The circuit has no stable state. The circuit changes its state alternately. Hence, the operation is also called free running oscillator. That is, a stable multivibrator also called the free running multivibrator. The output waveform, the stable multivibrator, is shown in the figure, that is square waveform. A comparison between monostable and stable multivibrator. Whereas in monostable multivibrator, it has only one stable state. In a stable multivibrator, there is no stable state. Here in monostable, trigger is required for the operation to change the state. Whereas in the stable multivibrator, trigger is not required to change the state. Hence, called free running. In monostable multivibrator, two comparators R and C are necessary with IC555 to obtain the circuit. Here in a stable multivibrator, three components, that is RA, RB and C, are the necessary with IC555 to obtain the circuit. The pulse width is given by T is equal to 1.1 RC second in monostable multivibrator, whereas in the astable multivibrator, the frequency is given by F is equal to 1 by T. And the frequency of operation is controlled by frequency of trigger pulse applied in monostable. The frequency of operation is controlled by RA, RB and C in astable. Last one is the application or timer, frequency divider and pulse width modulation, etc. That is in monostable. Whereas astable multivibrator have the applications are square wave generator, flasher, voltage controlled oscillator, FSK generator, etc. Thank you.